and welcome. In this video, I'm going to be creating a game on the microbit that I call the brick dodging game. And here's how it works. You notice there's a pixel sort of falling from the sky and one down there. The one down is being controlled by buttons, the one up there is sort of falling. And when you get hit 3 times, you die. It says game over, and then it prints out the score. So the score is however many times you manage to dodge the falling brick. So what I'm going to do is I'm going to divide this tutorial in 2 parts. Part 1 is going to just draw the brick that's falling, and part 2 is going to move the pixel at the bottom. So we're going to separate the player and the brick. And when we're done with both of those programs, we're going to bring them together. Okay. So let's get started. We're going to start by Googling microbit Python. Let me switch you to the screen. We're going to start by Googling microbit Python. And we're going to open, I guess, 2 copies of default programs, which I'm going to put together. You can have 1 or 2, that's up to you. I just find it easier to demonstrate if I do this program in 2 parts. So what am I going to do first? I guess I could do the player first, actually. Why don't I do that? Okay, so let's do the player. So what do we need? What does a player need? A player needs an X coordinate, a Y coordinate, needs to get drawn, and he needs to change the X coordinate according to the button presses. So why don't we just create player X? And that's going to be at the bottom. So it's, no, but that's going to be 2. And player Y, I believe that's going to be 4, but we're going to find out when we run the first program. By the way, like, I don't edit anything about these videos, so you're going to witness some troubleshooting here. So we got player X, player Y, and we can change player X depending on what happens when we press the button. So if button underscore A dot is underscore pressed, then we can say player X. A is the left button, so the X is going to change by 1 to the left. And we can, by the way, typically in Python, an if statement looks like that, but I want to do them on the same line because it just sort of saves space. So player X is going to go up by 1 if button B is pressed. So now that you've sort of checked if the button has been pressed, you still need to display it and leave it displayed. Set pixel, and then we're going to go player underscore X, comma, player underscore Y, and we're going to go strength of 9 and a delay. So that's going to say sleep 200. Now this code isn't complete. It's going to be crashable by moving sort of the X out of the range of available set pixel. But let's just test it, because in theory, let me connect the microbit. In theory, this should be able to move the pixel. So we've got that. We're going to download into the microbit, click save. That's going to take a few seconds. It's blinking at the back. That's how you know it's going on. Okay, so I'm moving it. It's not erasing, so that's another mistake. But by the way, it's still crashable. I'm going to crash it, and it's a value error because we go out of bounds. So after showing it for 2 seconds, you should clear, display.clear, and you should also write some if statements to keep the X within sort of bounds. So basically, if player underscore X is greater than 4, because 4 is the upper limit. If it's greater than 4, then you set it to 4. And if it's less than 0, you set it to 0. So if it's less than 0, you set it to 0. So this should be it. Let me save. Player X should be movable at the bottom of the screen. By the way, I probably should have mirrored this because my instincts of playing this game are so bad because I kind of go in the wrong direction. Okay, so that works. Now, that's part 1 done. Now we got to worry about what to do for the bricks that are falling down. In fact, I might just copy this code and just have a think about, because there's some similarities, right? There's going to be brick X. There's going to be brick Y. Now, brick X is going to be a random, right? Because you want the brick to fall from a different place. So we're going to import random, and brick X is going to be random.randint 0 to 4. Brick Y is going to be at the top, which is 0. And brick Y isn't really going to have any of these constraints. It's going to have one if. So brick Y is just going to go, brick Y is going to go up by 1 always. And if brick Y goes, if it starts at 0, if it goes greater than 4, if it goes greater than 4, then we need to do 2 things. We need to actually reset the original, like just go back to the top, right? This should do it. And then we're going to do the brick X and the brick Y, and we're going to do the sleep. This really should, I repeat, I predicted that some things are going to go wrong here. We've only had, well, we had no real errors yet that we haven't predicted, but I'm predicting and predicted errors. But that works, that's beautiful. So yeah, that's random rain of bricks. Okay, so now we've got these 2 programs, and we need to put them together and then figure out how they're going to relate to each other and how we're going to sense the collisions. All right. So I guess some copying and pasting is in order. We're going to put the player X, player Y there. Let's put the player logic in. Let's paste it there, and then I'll figure out how to. So let's say at the very start we're gonna check if this happens. We should print them pretty much at the same time on top of each other. And there is also that cool trail which I want to replicate. So we can get rid of this. That is the player logic, really. That's player logic. That there is the tiniest of brick logic. And I guess if after processing the player logic and processing the brick logic, we may as well draw them and then check the collision, right? So check collision. But before that, I want to see if I can actually leave a trail of bricks. And this should be straightforward. I mean, I guess we can just check if brick Y, so we need the brick Y starts off at 0, goes up to 4. So you cannot draw a trail when brick Y is, when brick Y is at 0, I guess you could draw a beginning of the trail. If brick Y is greater than 0, we can try to set a little bit of a trail at brick y -1. And we could set that to be 6. And if it's greater than 1, we can set a more distant trail of where it is to like maybe 2 or 3. Let's test this out. This is a whole lot of new code. I am expecting some errors here. Let's have a look. All right. If everything works, bricks are going to be falling with trails. We have everything but collision code. And we have an error in line 25. I mean, this is fantastic, actually. 25 is pretty high for our first error. Where was it? What is lid syntax? Invalid syntax. Was it 25? So we got brick X, brick Y here. The strength is 9. That's good. If brick Y is greater than, you got these sillies. Let's try this again. Okay, we've got line 26, value error. So something's probably out of bounds on line 26. Let me just neaten this up, index. All right, so I need to have a think about how is this departing from index? So, because this is greater than, this should be greater than 1. So if you're drawing, if brick Y is 1, you should be able to draw at Y -1. Let's try that one more time. Because that one draws a trail of 1, and it begins when the brick is already at 1, so greater than 0. And that's, if it's greater than 1, it should draw 2. Beautiful. Here it is. And so currently there's no collisions. We're going to need to basically create some code for collision. But it is actually falling with a trail from the sky, which is what we were going for. So 12 minutes in. Okay, we are one if statement away from actually having a game on our hands. And then we're going to have a think about how we can make that game better. So we just need an if statement. And I guess we could actually have this if statement after we've drawn them. So you just need to check if the brick and the player are in the same place, which is really, really easy. If brick X double equals to player X and brick Y equals to player Y. I mean, you should almost say equals to 4, but this makes more sense. Like, if they're in the same location, what to do then? Well, we can do like a blinky loop and then a break for I in range. Let's say 5. So we have 5 blinks. We can, doesn't matter which one we use, we can actually blink it on, leave it on for, even if it's 1. So leave it on for 1. Display dot clear sleep 100. So what's going to happen, even if it's 5 is going to be 1 second. Yeah, so it should make like 5 quick blinks. And these should be fairly clearly visible. And we have our game at this point. Like, this is it. After that, we need to just work on making it harder with time and having, say, 3 lives. But now, when it crashes, when the two things collide, you should see interesting that it happens. I'm not against this, actually. How it moved one place back. Where it's... So, brick X... Oh, because I said brick Y minus 1. Silly man. Brick X, brick Y. So, that's going to work. I don't even need to check. And so, what's next? I mean, we can... Okay, so there's been a collision. We could break and finish the game. But let's give ourselves 3 lives, right? So let's say lives equals to 3. And we can now say while lives is greater than 0. So when lives gets to 0, so lives is 3, 2, 1. So that's going to give us 3 lives. And when we get hit here, we can lose a life. Lives minus equals to 1. And we could just regenerate the brick the same way we did over here. We just regenerate the brick at the top. Oops. So that will be brick X. And yeah, that should work. So that's the sort of almost the clock of the game. And when the game is over, we can display dot scroll something really score. Aha. So we needed a score variable. So score, and I guess score equals to 0. How do we iterate score? I guess we could make it go up by 1 every time it hits the bottom here. Yeah. Score plus equals to 1. So the score will not go up by 1 when we get hit by the brick, but the score will go up by 1 when brick misses us. And so we've got everything. We've got score, comma, score. We have a trail, we have a score, we've got 3 lives. If this works, our game is going to be complete. Oh, we can also make it go harder with time. But let's just see this. Remember, 3 lives. Luckily, I am bad at this. Otherwise, I would last a very long time. We're surviving. We're running away. And we get hit the 3rd time. That was a bit quick. There is a manual delay if we use it. Delay equals to 150. I think that's the default. And probably we can just display the score twice. Let's try this. Download. All right. 1, 2, 3. We're hit 3 times. And line 45. How does the standard delay work? I was pretty sure that we needed to add score because the speed was actually defaulting at 150, but this is not a print statement in Python. This is a concatenation. So this is going to be string of score. Now, my excuse is I mostly program Python, not MicroPython. So this was a Python mistake. This is a display.scroll, not a Python print statement. But it's gonna work now. I promise. I'm confident. Like 99%. dead once, twice. We'll just stay here. Score. And it should be like 1 or 2. 1. There you go. So everything works. We have ourselves a game. We just gotta make it a bit harder with time. Now, this is not very difficult. You can easily say 200 here. That's the delay. And you can minus a multiple of score. Minus score times 5. Now, minus score is going to be fair enough. That will sort of cap your score at about 200. To make sure that this number never goes negative, you could just say absolute value of that. So technically, if you somehow survive the point where these things drop down super fast, you're going to actually have the game become easier as the score becomes a higher and higher and higher number, because the delay is going to grow. But alternatively, we can just go, if score is less than 1900, 190, then you could sleep 200 minus score times 5, something like that. And else you can sleep 10. So the game will get pretty much impossible by the time score gets to 40. So you're going to witness it actually speeding up. Ideally, I would make this much less. Maybe make that times 2. So score 100 is like a super good score. But this is it. This is just a demonstration. So yeah, I don't know what else to... Perhaps I can just backspace it like here so that this is, streamlined into less code. We've crushed these if statements, so we've only got 45 lines. If this works, the game is actually going to be getting harder with time. You will have 3 lives. You'll get to move right and left. Pretty much all of the cool features you could want in a game like this. So here we go. We've lost 1 life. We're just wanting to witness. Run away. You could tell that it's getting faster. But we're still surviving. It's just falling real fast. We got hit. But our score must be like close to 20 or more. 34. So there you have it. That was the brick dodging game. Now let me just come out of the thing. And here I am talking to you face to face. I hope you enjoyed that. If you did, subscribe below on the side. There's going to be subscription links. And while you're at it, check out my other microbit Python tutorials. I did a button masher game, which is like a cookie clicker here, and a reaction time game there. That's all. Bye-bye.